Here's a prelim question that asks you to convert the function f2 into MIPS assembly. There's going to be three parts to this. The first part is to convert the body of the code into MIPS. That's this C code here. The next step is going to be to prepare to call function 3. That's going to be assembly that effectively goes right here. And then the third step is going to be to write the prologue, which is the MIPS assembly that happens prior to the body. That's going to go right here. The question has a further stipulation that is that we are supposed to store the value y in register T1, and we are supposed to store the value z in register S1. And the reason we're asked to do that is because one of these is a caller saved register and one of them is a callee saved register, and we're trying to test whether or not you know how to treat each of these register types. Okay, let's start by writing out the body. The first line of code that we can execute is this line of code right here. Now n is an argument into the function, so it's located in register A0, and we've been told to put y in register T1. To multiply by 2, we simply shift it left by 1, so that's going to be a shift logical left. We put the result in T1, and we are shifting the value in A0 by 1. Next, we are going to add 1 to the value n, and this is going to be the value z. Z we've been told to put in register S1. So here we're going to use an add IU. The value is going to go in S1, and again, it's the value n, which is still stored in register A0, and we're going to add 1 to it. At this point, we have actually converted the entire body up to the function call f3. Now we need to start preparing to make the function call f3. And there's going to be two things we have to do. The first is we need to save any caller saved registers on the stack. And then the second thing we have to do is to give f3 its arguments. And since there's only 2 arguments, that means putting the address of x into register A0 and putting the value of n into register A1. We can begin by saving the caller saved register T1. Now, the reason we know we need to save T1 at all is because that's what's holding our value y, and we're going to need the value y here after the function call. If we didn't use y after the function call to f3, we wouldn't actually have to save it on the stack. But as a caller saved register whose value we are interested in after we return from f3, we have to do this. We're going to store word, and the value is going to be T1, and we're going to store it somewhere on the stack. And until we actually have a diagram of our stack, we don't really know exactly where we're putting it. So I'm just going to say it's going to be somewhere off of the stack pointer. Next, our 2 arguments, the address of x and n, need to be put in registers A0 and A1 respectively. The address of x is really the only truly tricky part of this prelim question. If you need an address of something, it cannot be stored in a register. Only a value in memory has an address. So this means that while you were told you can decide where to put the value of x, x has to go on the stack. Again, we don't have a nice diagram of our stack yet, but eventually offset somewhere from the stack pointer is going to be the location x. And we're going to temporarily calculate that address by performing an add IU. We'll just put it in a temporary register, T0, and we're interested in getting the address of the stack, and we're going to put some offset on it. In fact, maybe I should give it a different value so that we're not confused here. We'll call that YY. Now register T0 contains the address of x. We need to move the address of x into register A0. So we can go ahead and do that. But currently, A0 contains n, and we want A1 to contain n. So before we overwrite n in A0, let's go ahead and move the value of A0 into A1. Okay, so what we've done is we've taken the n that was here and we've moved it into A1. Okay, now we can go ahead and move the address of x into A0. And again, that was T0. And now we're ready to perform the function call. So now the call to F3 is simply a jump and link F3. Okay, so at this point we have translated the body of the code, including the code preparatory to the function call to F3.